Hello everyone, I am Anushri, second year BE in Information Science and Engineering student at Sri Venkateshwara College of Engineering, Bengaluru. So my topic of presentation is wireless network sensors and microcontrollers. With no time, let's move on to the contents or today's agenda. That is to introduction, architecture of WSN nodes, architecture of a sensor node, characteristics, factors influence, and applications, advantages, disadvantages, operational challenges, future, and lastly, conclusion. So, introduction. A wireless sensor network is a wireless network consisting of a spatially distributed autonomous devices using sensors to cooperatively monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion, or pollutants at different locations. A collection of sensing devices that can communicate wirelessly is called as wireless sensor networks. A wireless sensor networks, even though wireless sensors have limited resources in memory, computation power, bandwidth, and energy, with small physical size, it can be embedded in physical environment. Self-organizing multi-hop ad hoc networks. Here you can see a user who is using an internet to connect to a gateway node, and the gateway node is connected to several numbers of sensor nodes. Wireless sensor network architecture, these small circles in blue color indicates the sensor nodes and the large circle indicates the gateway sensor nodes. These all small circles, that is sensor nodes, are connected to a gateway node which is indirectly connected to a user. Architecture of a wireless sensor nodes. Special addressing requirement is required. So local unique address, data centric. Example, each node has a unique number. Attribute based naming architecture. Data is named by one or more attributes. Example, each node is distinguished by an attribute. GPS sensors are practical example for this. Wireless sensor node. So, what do you mean by a sensor? Sensor is a transducer that converts physical phenomena like heat, light, motion, vibration, and sound into electrical signals. So, what is the sensor node? Sensor node is a basic unit in a sensor network, contains onboard sensors, processor, memory, transceiver, and power supply. Here, the processor is used to manipulate or process the data, and the memory is used to store the data. Transceiver is a combination of, it's an electronic device that is a combination of transmitter and a receiver. So onboard sensors are used to sense the signals such as heat, light, motion, vibration, sound, and obviously a power supply is used to uh, provide the current. So sensor network. Sensor network consists of a large number of sensor nodes deployed either inside or very close to sensed phenomenon. Architecture of a sensor node. We have transceiver, that is a combination of transmitter and a receiver, and a microcontroller which has the storage capability and external memory, power source, sensor 1, sensor 2, ADC. ADC is an analog to digital converter. So it converts the analog signal into digital signals. So microcontroller is used to store the data which has ROM, RAM, and everything. And transmitter or a transmitter come receiver, that is a transceiver. It is used to transmit the signals or receive the signal. So power supply is used to supply the power, and external memory is used to store the data. Characteristics. Power consumption constraints for nodes used using batteries or energy harvesting. Capability to cope up with the node failures. It has the ability to cope up with the failure of a node, that is resilience. Mobility of nodes, heterogeneity of nodes. It has different types of nodes. Scalability to a large scale of deployment. Ability to withstand harsh environmental conditions. Ease of use, cross-layer design. Factors influencing WSN design are fault tolerance, that they can tolerate the faults, and scalability, production costs, hardware constraints, sensor network topology, environment, transmission media, power consumption in sensing, communication, data processing, cost and ease of use, system maintenance, overall planning and robust architecture, intelligence or real-time monitoring, autonomous operation, energy efficiency are some improvement factors. Applications. Military applications, environmental applications. It's also applied in health, home and office, automotive applications, and other commercial applications. Advantages: it avoids lot of wiring. It can accommodate new devices at any time. It is flexible to go through physical partitions. It can be accessed through a centralized monitor. Disadvantages are: it is lower in speed when compared to a wired network, more complex to configure than wired network, gets distracted by various elements like Bluetooth, still costly at large. It does not make sensing quantities in buildings easier. It does not reduce cost for installation of sensors. It does not allow us to do more than that can be done with a wired system. Operational challenges of wireless sensor networks: energy efficiency, limited storage and computation, low bandwidth, and high error rates. Errors are common: wireless communication errors, noisy measurements, node failure are expected. Scalability to a large number of sensor nodes, survivability in harsh environments. Experiments are time and space extensive. Future of WSN. So, as we already have a smartphones, so we can expect smart home or a smart office in our future. So, sensor controlling appliances and electrical devices in our house, better lighting and heating in office buildings. So, in this diagram, you can already see a Pentagon building has used sensors extensively. Conclusion: WSNs are possibly due to a technological advancement in various domains, envisioned to become an essential part of our lives. Design constraints need to be satisfied for realization of a sensor networks. Tremendous research efforts being made in different layers of WSN's protocol stack. So that's all for today. Thank you.